All right, today we're going to be talking about similar polygons, which are just similar shapes. We're going to slowly transition this into similar triangles eventually. So similar polygons, they have the same shape, but not necessarily the same size. So you could have two triangles that are not going to be the exact same size. They have congruent angles, which means the angle measurements should match up, but they have proportional sides. All right, in a similarity statement, we use little swiggle that we call a tilde to kind of signify it. So here's an example. If triangle ABC is similar to triangle XYZ, then, so we have our picture here. So if this is true, we know that angle A and angle X are going to be the exact same measurement as angles. So angle A and angle X are going to be the same. Angle B and angle Y should be the same. B and Y. And angle C and angle Z should be the same. Okay, and their sides should be with proportional sides. So this, when we compare side AB to side XY, that fraction should be the same as BC compared to YZ and CA compared to XZ. Now that might make a ton of sense right there, but I promise you once we do an example, it'll be a little bit more clear. So here's our first example. They want to determine if they're similar, and if so, write the similarity statement and give the scale factor. The scale factor is the ratio as which they are similar to. So what we're going to do first is we're going to see if all the angles match up. So I'm going to start with this bigger shape here. So I've got angle W should be congruent to, since that has the one swoosh mark, angle W should be congruent to angle P. Up next is angle Z. Should be congruent to angle Z has 2, so the one over there that has 2 is angle S. Angle Y would be next. Angle Y is congruent to angle R. And angle X is congruent to angle Q. So they have matching up angles, which is perfect because you want the angles to be the exact same amount. Now we have to figure out if they're similar by looking at their scale factors. You're going to compare all the sides. So here's kind of how I attack a problem like this. We're going to pick one side, PZ. Now, PZ should match up with PS. There's my first fraction, 9/6, which I think I can reduce over by dividing both things by 3 to 3/2. Okay, now I'm going to pick ZY and compare it to SR. So ZY goes on top, SR goes on bottom. We're going to reduce that. I can divide both of them by 3, so I get 3/2. So far, they have the exact same ratio. So far, so good. But we got to check all of them. We've got XY and QR. So I've got 18/12. If I reduce that, I get 3/2. So again, we're looking pretty good. And then the last one here, we're going to do WX and PQ. I get 12/8. I've reduced down to is 3/2. So I would say yes, these are similar shapes. All right, so I would say yes, they're similar. I'm going to name the first one. I'm going to name that one WZYX is similar to, name it in the same way. So if I do WZXY, I have to name it PSRQ. PSRQ. And the scale factor would be 3/2, that proportion we just made there. And that would be my final answer. That's one type of problem. You can see another problem that says these two are similar. So they're already telling us they are similar, which means they should have congruent angles but similar or ratio sides. We need to find the values of X and Y. So we have to make up some equations here. All right, so we're going to start with X here. So I want everyone to find X. X is right here. What side should relate to that or be similar to X? Well, that's on ST, so that should be similar to NP. So there's my first ratio, X/13 equals. We want to set up a proportion here. You're looking for two sides that we definitely know the numbers for. Okay, so this one, I've got the 32 and the 16. And I also have the 38 and the Y. Let's avoid the 38 and the Y because we don't want to have multiple variables. So we're going to just focus on that 32 and that 16. So I'm going to say 32/16. Now we have that problem, we can cross multiply and start solving. So I've got X times 16 equals 13 times 32. Over here I get 16x equals 416. Divide both sides by 16, and x equals 26. We're going to do the same thing and try to find y now. Now again, we know y, we've got the 38 and the y. So I've got 38 divided by y equals, again, we want to find two sides that are going to be the same. So we could use our 26 now because we know that this is 26. So we could say 26 over 13 over here, or we can use the same one as before. So we can use that 32 over that 16. We're going to cross multiply now. So we've got 38 times 16 equals y times 32. That gets me 608 equals 32y, which means y equals 19. And we've completed that problem. All right, this one says, it's telling us that these triangles are similar. Find the scale factor of DEF to GHJ and find the perimeter of each triangle. So I have to do a couple different things here. So if we're looking at this, we can already find the perimeter of this triangle right here. The perimeter, if I add up 10 plus 12 plus 8, would be 30. Now the issue for this perimeter over here is we don't know all the sides. We are only given one side. We've only given that 12. So let's find our scale factor first. Our scale factor is you have to pick two sides that are similar that you have both information for. Well, we only have one side over here. What side should match up with this 12 on our first triangle? Should match up with that 8. Oops. So my scale factor is going to be 8 over 12, which we can reduce by dividing both of them by 4 and get 2/3. So our scale factor is 2/3. Now, in order to find the perimeter, we need to find both those other sides. So I'm just going to label this side x and this side y, and we're going to solve like we did before. Okay, so I can do 8 over 12 equals 10 over x, because the 10 and the x are similar sides. I can cross multiply, and I get 8x equals 120. Divide both sides by 8, and I get x equals 15. So now I can erase this and put 15. We do the same thing for y, so I'm going to say 8 over 12 equals, my y goes with that 12 there, so 12 over y. Cross multiply, I get 8y equals 144. Divide both sides by y, or divide by 8, and I get 18. So my y value is 18. So I can cross that out and put that 18 there. So now I can find my perimeter by doing 15 plus 12 plus 18, and I get 45. All right, last problem here. Same thing, they're telling us the two sides are similar. We need to find the value of x. Now the only issue here is our triangle isn't really the same direction, so we have to make our proportions, kind of figure out things from there. So if I look at this, I am given some sides here. I'm given this 6 and this 12. Over here, I'm given the x plus 3 and the x minus 3 and the x plus 1. So we have to figure out kind of which one goes with which. So what I'm going to do first here is I'm going to pick the side 6. 6 is on side AB. AB is the side that is in between this one swoosh angle and the 40 degrees. So the one swoosh angle and the 40 degrees is the side over here. So that should go with that x minus 3 equals. The 12 is between the one swoosh and the two swoosh. So one swoosh, two swoosh is the x plus 1. From here, we're going to cross multiply and solve. So if I cross multiply, I get 6 times x plus 1 equals 12 times x minus 3. We're going to go ahead and distribute and solve. So 6 times x is 6x. 6 times 1 is 6. 12 times x is 12x. 12 times negative 3 is negative 36. I'm going to subtract that 6x over and add the 36. When I do that, I get 48 equals 6x. Divide both sides by 6, and I get 8 equals x. If it also helps you too, you're more than welcome to redraw this baby triangle here. So if I redraw it so it looks like this, just smaller. All right, I know my 1 should go there, my 2 and my 40. So that means that this is my D, this is my E, and this is my F. I know that DF is x plus 1, and DE is x minus 3.